Oh, making a video. Yeah, back on the Drake equation. So some guy who, I don't remember his name, post the link below. Nice enough sort, but he seems to like to make response videos that are kind of on, I don't know, obscure angles on subjects. So first we argued a little bit about death and the fact that it's sort of built into our genetic code. And now this time it's the Drake equation stuff. And so, in the video I basically point out how, there needs to be, people have to get a little serious about this whole life in outer space thing, the whole idea of abiogenesis and how it took place on this planet, what the, what chemistry really does do, what is normal chemistry and what is extremely aberrant chemistry. And the truth is, reproduction, especially the kind that can evolve, is extremely aberrant chemistry. Alright, it's like super double ruby. Okay, we haven't found any super double rubies yet. Maybe they're out there. We haven't found any because it's really aberrant chemistry that creates super double rubies. What probability conclusions can be drawn from the evidence that exists? What kind of surmises? What kind of conclusions can be drawn from the evidence? That's the thing. And so I think I'll use this video as a platform video. And if you have some good links, post something like a link in the comments or something, and then I can repost it in the description if it's a good link, to content that in some way is, says something important here, and says something in terms of ordering this argument, because these are bogus arguments. Whether I have to go through a whole probability course or whatever, but like I said, I was basically in the video saying you can't keep making these bogus arguments, and the guy basically just makes the same old bogus argument. And it's just, what the hell? That's not good enough. The fact that, life started lifing early in the history of Earth is not a fact from which we can glean anything. Especially without knowledge of the fact that it actually competed against other life forms or some other kind of evidence. Without some evidence that it was in some sort of dynamic competition, it just doesn't demonstrate anything about feasibility of life chemistry. One result, like I said, I could have a lottery. I could throw 10 million jelly beans in a bucket, a really big bucket, and then have you pick, right? And there's only one black one, and the rest are all white or green or red. And, maybe on your first pick you pull the black one out. Does that mean that black jelly beans happen all the time? Does that mean that the bucket is full of black jelly beans? No. It doesn't mean anything. It just means that circumstantially it happened because the circumstances were right. The necessary 7 lightning bolts, struck the same head of a pin, and it doesn't mean anything. You can't draw any conclusion from one sample. One sample doesn't tell you anything about likelihood, and that's like sort of law. I mean, it's the law of math. Okay, it's the law of what you can rationally, reasonably, logically glean from sampling, and what kind of probability statements you can make from evidence. So let's have a rational discussion of what the evidence indicates. And I'm going to argue that we need to list these kind of arguments. I have the argument I never really hear from anybody, but I think is a really important argument, is where is it? Where's the other life? 4 billion years, our planet has been littered with DNA littered with all kinds of building blocks, all kinds of amino this and acid that and all that crap, and yet not one other biological life form, not anything close to a replicator, has showed up. That isn't really close, that isn't descendant or materially connected to the DNA molecule arrangement that is our ancestry. That's the only lineage on this planet. There's one tree of replicating chemistry on planet Earth. Just one. And there has to be some sort of reasoned explanation for why in no other circumstance, in no other environment, no other anything here, there's no evidence that it ever happened again, that the process initiated. And some people claim that, well, life would eat it and all this kind of stuff and blah, blah, blah. Yeah, life is abundant and numerous, but it isn't exclusively, doesn't own every inch of this planet. And there's just as much, it can be speculated, just as reasonably, that a new life form, a new construct of membrane life, not only would it be not something is used to eating that exists now, wouldn't be on its recognizable food menu, wouldn't know to eat it, but second, it might have properties that make it incredibly dangerous to go anywhere near. It might be made of arsenic. It might be made of some other compound associated with it that would be incredibly toxic to the current existing life forms. It might find life inside of ourselves as a parasite. It might find ourselves to be a very comfortable pre-made house. It might just decide to move right in. And because there is no other thing like it in evidence anywhere in the history of life on Earth, our cells would have no necessary defense against such a mechanism. So just like a virus, it would invade pretty much unmolested. Once it was in for good. Well, whatever. I don't want to make all the arguments now. I just want to sort of make a highlight reel that there are some conclusions we can draw. There's some language we can use reasonably. And what we can say is, I think beyond all doubt, we can say that replication is not common chemistry. That's an undeniable truth. That replication is not simple chemistry. It does require complex arrangements of compounds, more than one compound, and the compounds must, through some momentum exchange of energy, some interaction, they must dance together in such a way as to create viable replication. That is, replication that creates a replicator. It's more than just making something that looks like what you look like. It has to function like you function. So it has to duplicate the entire Xerox machine, not just the copy of the machine, so to speak. Whoops. Wrong way. Yeah. That way might work. I haven't gone that way yet, but it's unlikely. Probably huge, snarly, nasty bits that way. See, the animal tracks know. They know this is the right way. We get to Gary's house and steal his stuff. Anyway, where was I? Yeah, so, and then so, we can draw conclusions from the other planets. Some of them are very active, very hostile by our standards, and energetic anyway, like Venus. Too energetic, some would argue. I might be one of those. But anyway, we do have variants already existing, and I'm sure the life cycle of those planets has had that variance. I theoretically, I suppose, it might be a theoretical possibility that life at one time existed on Venus, and that the life soiled the atmosphere, and that it couldn't recover in time. It couldn't. It just couldn't. It couldn't do anything. Once it soiled it, once it greenhoused it, and then that spiraled out of control, and the plant never recovered. Something like that is possible. But anyway, that's not the point of the video. The point of the video is that we don't have any evidence that other substances or compounds form into replicating arrangement. We can't synthesize one of these things. We haven't been able to make one with all the king's horses and all the king's men. We can't make Humpty Dumpty again. We haven't made a Humpty Dumpty. Haven't made an egg. So there's another strike against the chemistry being something you can, even with our intelligence, we can't synthesize an environment that would accidentally or inadvertently or in some way create the phenomenon, the arrangement, the circumstance that enables chemistry to replicate. That's a telling bit of evidence, I think. Certainly not conclusive evidence, but it's one more piece of circumstantial evidence indicating rarity, difficulty, elusiveness, that this replicating thing is not, is rare. We can use the word rare. I mean, it's rare chemistry. At least. That's the minimum. It's rare. We need more evidence to say conclusively that it's basically impossible, and that we are the, improbable black jelly bean in the barrel. We don't have enough evidence to say that yet, but there is circumstantial evidence indicating that this is a bizarrely bizarre circumstance. Not only do you have to overcome the hurdles of abiogenesis, but if you want to get to intelligent life, sentient life, all that, you got all these other obstacles in the path of evolution. Our very existence is a phenomenon not regularly, that doesn't happen usually through evolution. It can be described as another rare event where we were given a brain that had potential that we weren't using fully or even close to completely. And yet we not only got the attributes, the ability to do language when we didn't have a language to speak, which is really weird. But yeah, we got it, and we were able to retain it through evolution long enough to actually realize its potential. And we now have to survive the dangerous position of being in where we have a little bit of knowledge, enough to build a nuclear bomb, but not necessarily enough knowledge not to use the nuclear bomb. So, even we haven't even yet demonstrated the survivability of intelligent life, let alone the idea that it's some sort of phenomenon common to the universe's function. Yeah. So anyway, enough of the video, I believe. So anyway, I'll probably make future videos and attempt to relate them back to this one, and attempt to expand the description section as warranted. Yeah. So next time and such. Yeah, cat. Yeah, I didn't like being out. I know, Will. Yeah, you went out and I went to work, so. Oh, door's locked. Hooey. Till next time.